All right, we're continuing to the more of the static section. So we're doing this part over here. What we need is to the centroid, which is, I believe we denoted by I. No, the centroid. So we denoted by XAC. My apologies. So how do we do this, you're asking? Well, it's actually the summation, if I remember correctly, of what was it called again? AI by XI AC divided by summation of AI. Now, I know for a fact that they do something weird where they do this little bit over here where the centroid of area is this thing. I don't like the definition they give over here. It is too what's the right word? Annoying to me. It's too what's the right word? It doesn't directly show everything at once. For example, technically these two are equivalent. Yes, they're the same, but I don't like the denotation they use over here because what is AN? They don't really explain what AN is. But if you do it this, I mean, if you do it this way, it makes more sense to me. What is AN? Well, that's area of a specific region, right? That makes perfect sense. This just confused me. Would have confused me. Okay, and you see here, the definition over here. You can extrapolate over here what it means over here. Basically, summation x I a I divided by a summation. So I like this version better. So what does that really imply over here? So there's three regions I will play over here. One, two, and then three. Now the triangle, for me, I already memorized it. It's one third because of how much my professors kept on emphasizing it. But you can look over here of a triangle and see that it is one third on all of them. Why is this one bugging me out? Well, basically for a triangle, it is one third. So what I can say to solve this one is basically XAC equal, first of all, sum all the areas up. The sum of the area over here is 2 by 5, so that is what? That is 10, right? Sum of the area again of this section over here, and that is 2 by 8, which is 16, right? Sum, I. And then this over here is, you're going to divide whatever you multiply here. So it's 2 by 8, so 16. So it's 10 plus 16 plus 8, which you can grab a calculator. You don't have to because this is 26 plus 8, which is 14, 134. You can grab a calculator if you want. It's your choice. It is 34 meters square. And just in case, you can grab your calculator and write 10 plus 16 plus 8, which you can delete, and you get 34. Yep. I'm done with that section. Now we can now go to the other section. What did we say about the other section? Is summation of AI multiplied by x position I. So for first one over here, it was 10, right? If that was 10, you need to multiply by the x position, which was 1 centimeter. Huh. Okay. Now plus over here, this over here was 2 by, so 16, right? And this was in 3 centimeters. Huh. And then plus so on. Over here is one third, so one third from this tip over here. So it would be two. It would it would be between 4 and 6, and it would be one third of that. So it would be 4 point. Oh wait, there's 5 in between, right? So it's 2 divided by 3, right? Plus 4, right? So whatever that is. So 8 by 4 plus that should be good. So again, this is the formula that I found. You just plug it into the calculator, which is 10 plus 16 multiplied by 3 plus 8 parentheses division 4 plus 2 over 3 parentheses 34. And we hope we get an answer that is, I get AAC equals 10 plus 16 times 3 plus 8 times 4 plus 2 divided by 3, all divided by 34 equals 2.80. So that means it is B. All right. So it is B as in B. Okay. Next one over here. There's two questions over here. I think we'll start with this one over here. All right. This is the only question that made me go watch like several YouTube videos and make me remember this stuff. Okay. So how do you solve this? Is the question. Now, you need to understand how zero force members work. And if you know that, you know that this is a zero force member. Why? Now, I want you to imagine a trust like this, right? And there's an internal force over here trying to go this way, an internal force when you cut it this way, so you're cutting this, going this way. Well, then this over here will try to go downwards. Okay, well, that's fine. Imagine this. How about if we have a force like this and this? That cancels out the x. No, there's a force total that's trying to go this way. and your total shift. Basically, what I'm saying is it's turning into dynamics and not turning. This is trying to go down, so it's turning into dynamics, and we're breaking the sum of forces equal net equals zero, and that is a problem for a thrust that's trying to be a static question. I just know. So what that means? Oh, anyways, huh? Okay, that gets rid of this portion. Okay, how about this? Well, when we have something like this, imagine a force going this way, internal force. We're cutting. We definitely have to cut. If we don't cut, then we get nothing. So imagine an internal force going this way and this way. Okay, those cancel out. But if you put a force here, this red dot is trying to move over here and changing to a dynamic question, not static. Okay, but but there's three of them, so we can surely do this, and something like that. Well, yeah, I don't see any problem with that, right? So we need to look at some other points to figure this one out. Over here, okay, that can give you a normal force. All right, that's fair. This can give you a right force and a left force. Okay, that's fair. But oh, wait, how about this one? This one has this force. Oh, shouldn't this also apply with those rules? No, because there's an external force. So when there's an external force, it plays differently, and I'll explain that later. Because it's really just because you can make it not move. But over here, we have to figure out how this over here can be zero. And we will explain it because this has to be zero somehow. And right now, there's no way for you to understand it. So how we understand it is we have to look at G. G has a force this way, G has a force this way, and a force this way. Now, we know that this W over here, or whatever weight here, I'll just call it W for now, can be described, yes. And this W, for lack of a better word, has a way to make a force go up, which makes a separate, let's just say green force over here, going this way. So this red force must be a force going that way. Okay, we established that there's an internal force that can work. And over here, we see that over here. So let me just draw the whole thing now, because now you guys kind of understand what we're going through. We can kind of now draw the whole thing. This question basically took a while because I was trying to figure out zero member force because I forgot it for so long. So I never use it. I'm in fluid dynamics often, so I don't really touch this thing often. So this is a good review. And then I'm doing what's again? FEM soon. So this is a really great review for me because there's zero member force all over that stuff. Anyways, no, this is going bad. Okay, so as we discussed earlier, if we cut it, there's a force over here there's a force over here, and we discussed that it's going outwards here, and this is going inwards. This indicates a tension. This indicates a compression. Because we're looking inside now, not looking outside. We're cutting things and figuring it out, which is a little different. It's kind of the opposite way of thinking. I mean, it's kind of really counterintuitive because if you think about it, it's usually tension, you think of this, but if you were to cut this inside and look inside, you're looking at a force that's going this way. It's very counterintuitive. But once you get it, you get it. It's just a little bit opposite Houdini stuff. Okay. So as we discussed, over here, this force over here and this force over here will make it go up, or it'll make it go this way, or it'll make it go down, one way or another. This is not possible to have a force. If it does, then you have structurally fucked up, genuinely, in your code. Because I'm thinking in the context of you writing a code for this thing. So if you're writing an EMM, whatever, it doesn't matter. Now we know that this over here has to have a force this way or this way. Right. Okay, that's a good thing. There's no indication yet of any other zeroing. Okay? So what we have to do is accept that this is the truth and move to the next thing, right? So we move over here, and we now. Oh, actually, I can't do that yet. Sorry, my apologies. We have a force over here. We have a force over here. We have a force this way, right? And this will be F. This will be G. This will be E. This will be C, and that would be all. And I don't think any of these have a zero member frame because this doesn't have a parallel thing over here. None of this has a zero member frame. So I think we're good over here. Now, I think we're good. I think there's no other zero member frames here. Now, here's the thing. We have to care about certain aspects about this. So where are we gonna do a moment is the question next. And very logical answer would probably be E. You can choose E. You cannot choose G because G is the only thing, and you do not want to choose F. Now, here's the thing about choosing this. We need to figure out how the moment is created now. Now, if there was a force this way, I genuinely wanted to ask you this, and going this way, and we cut over here, okay? So what that does is at E, there's like a force over here, force like that, force like this, and there's a hard stand over here, and there's a force this way, so and a force over here. These forces are exposed because I am cutting now. And let me just redraw that because that was so bad. Uh, okay, so we're cutting this. So now the forces are being exposed internally. And actually, over here, for instance, I would rather you draw like internal. So it's going to be like this way, in my opinion, is probably the better way to draw it. So the only external is this one, which in the, is doesn't really matter here because we cut it. So we're exposing all the forces. Once we expose the forces, we understand that the line of action over here, or whatever they call it, this force, if we drag it out over here, is basically no displacement to create a moment. So this gets deleted. That's a powerful tool there. What that means is that we can create a moment because we can also move this line of action to over here. And we already know the distance over here. So we can do a summation of moment E equals 0, right? Right. So in that case, we already know 800 cm multiplied by 6600, comma 000 newtons is one of the moments, and it's going the negative direction. And we're going to add a positive one for this one, which we'll call moment of force CF multiplied by this distance over here. What is that distance? Well, this is 400, this is 500, so that looks like 300, right? So 300 over here. Good job. That must equal 0. So FCF equals 800 cm, and this is going to be more on the problematic situation of getting the units correctly, which I need to figure out. So 300 cm. So cm cancels out. So basically, what that means is 800 divided by 300 is fine, and then you're just going to multiply by 60,000. And mega usually indicates 6, so we're good about that. So 6,000 multiplied by 800. Just grab your calculator. I'm just doing it on my calculator, man. So it's 800. No way. Okay, we got that. And then 300. I get 1600, comma 000. So I get 6 zeros. It is C. Beautiful question, beautifully solved. Okay, we move on. All right, so this one we have to be careful here. But first of all, let's see what the question asks. It starts with basically 500 kilograms, so 500 kilograms. But because we're having like a equal distance like this, I'm assuming that it has to be 500 kilograms at this point, which means we can simplify it like this. If equable, so this cable is given. So there's B and there's FC. There's two unknowns. So in theory, the simplest of the three, like summation of x or sub equals 0, or summation of y equals 0, or summation of z equals 0 should work. And since z is the hardest because there's two forces over here that's going to be big, which basically if I were able to get rid of that, basically I won't need to use one of the variables over here. So we will be using summation of fx equals 0 and summation of fy equals 0. In that retrospect, I know it's a 3D problem, but we'll treat it like a 2D problem, and that's what we'll do. So FAD, so first thing we have to do is use a simpler method. So we're going to use FAD, summation of that. So first of all, we need to figure out what we're doing first. So uh, what is FAD first? That is equal to, say, 5950 newtons, and then we can do square root of basically 5 square plus 2.5 square plus 10 square. And we only care about the k and, well, we only care about, sorry, this is not right, k and z, because apparently this is y apparently. So z and x we care about. My apologies. So with that said, we can do, which one? Let's do I first. I in this direction, A is negative, so it's negative 10. And then it's going to be plus this one, so it's going to be minus actually, because of how it works. It is a minus 2.5j, right? So next we'll use F um, DC, or it doesn't matter which way you do it. We can write FC is equal to, multiplied by square root of, what is it? 15 square plus 7.5 square plus 5 square. With that said, we can do 15j I, sorry. Sorry, this is not j, this is k. My apologies. And anyways, plus 7.5k. Okay, so to make it visible. And the last one over here is going to be f bd, which is equal to saying square root of, oh, wait, we need to write this down. What was it? FB, I think. I don't know if it's right. I think it's right. FB is 5 square plus 5 square plus 5 square, which is IK, sorry. And I think it's going to be probably K direction is going to be -5, and then it's going to be 5. So let me calculate this now. We just have to add the rows together, so the i's with the i's and k's with the k's, and then we figure out the numbers basically. Notice how we exclude the force of the box because it's not needed because you gave me AD. It's a great way of saying, hey, what a useless portion of the question. So over here we can do FB 5 divided by, I don't know what this is, on second square root 5 square plus 5 square plus 5 square. And then we can do 5 divided by that, so it's a square root of 3. And then we can do enter, and then we can do summation. So what I get is, let me just write it really. Summation of fx equals, in my opinion, fb parentheses 1.73205. Am I correct about that? Maybe we're not. We'll see soon. Okay. Yeah. So next, what's the cable of BD? Um, yeah, that's right. So we do that. We plus that with 5950, and it's negative k. So let's add another zero over here, and we this with a negative. And then we do plus FC 15 divided by that. So we will just do the math on that one. So division 15 square divided by second square root of 15 square plus 7.5 square. There must be an easier way to do this, I think, because this way seems barbaric, to say the least. 12.85714. So there we go. There probably is a much easier method that I haven't thought of. Yeah. Anyway, summation of Fy is basically doing the same thing. So negative 1.43205 FB minus, again minus 2.5 multiplied by 5950 divided by parentheses second square root of 5 square plus 2.5 square plus 10 square, which is 1298.39. Maybe I made a mistake somewhere, but oh well. And then this is plus FC. There must be some easier way. I'm genuinely thinking there might be an easier way to do this, and I'm doing it the hard traditional way, which takes forever. Because all FE questions so far I have solved so far has a little trick to them that makes it easy. And if you figure that out, it's a 5-second question, and a five like 1 minute something. But if it don't, it takes like 10 minutes. And this feels like one that I would have like easier time if I figured out the trick. Okay, there must be a trick. I just don't see it. Yeah, I genuinely don't know what the trick is. Hmm, don't know. But you're definitely solving for this. And because I am lazy, I'm actually gonna do something that I didn't think I would do. I'll make this a system of equation and put it into my system solver 2x2 linear solver in my calculator, which would solve this. And because there's no way the author of this intended for me to figure this out by hand. I hope. I just hope that's true. Because if that's the case, then bravo to you. You are interesting. But nonetheless, I don't think so. So let me just use a system calculator. Um, it might take some time for me to like put it in because I am putting it in to my system calculator on the calculator they allow, I think. I'm pretty sure this is a scientific calculator they allow. That's the only reason I bought it. 57 and then 129.8.39. Okay. I get none of the answers. I must have done something wrong. Let me just check how I put it in the table first. Okay. I'm just gonna do this one more time. And then hopefully I'm just sleepy and that's why I messed up, but I have a feeling that maybe I did something wrong. squared. Why is this positive? It's negative. Okay. 0.577. Okay, 0.85. Okay. And then here's a mistake I made. Enter del. Okay, solve this. Okay, that's close. Okay. Um, I got to 1500 kilonewtons. Great job. Is A. My God, it took way too long. My apologies on all the mistakes I made. Hopefully it doesn't happen with this one. So here, a rope is supported by mass passing around four simple frictionless. Frictionless supported at point A, B, C, D, and around two fixed drum are point E and F. The mass exerted is 1,000 on the rope. The radius of all pulleys is 70. Why would that be important? If the coefficient of friction between ropes are added, then it's contact 0.3. Okay, so 0.3 over here. All right, the first thing we need to know is go to your equation sheet and find this equation out because you'll need it. Is how we calculate friction here. So all of this is just junk at this point. The only thing that matters is basically this portion over here. So let's redraw it over here, the important parts over here, because who cares about anything else? This is for the important parts. Actually, a lot of people care about the details because they're important too. Um, Otherwise, the system fails and you're effed. This is parallel to, oh my God, these drawings are awful. Let's just try to draw a decent circle. If I can't, I know there's like a way to do a specialized, maybe. Maybe this one. Circle, circle. Okay, there we go. That took a little while. We have this, and we have 60 degrees over here. Now here's the thing over here. This is 1,000 newtons. If we cut here, we realize that T1 must equal T2, right? If we cut over here. So that's the important thing to note over here. So basically, let me where's my drawing function? Okay, I need to go to sleep, honestly. It's very late at night. These two function T1 is T1. Understand that. Okay, so next is P. Okay, and then P is a work in progress over here. Basically, what you have to do is think about the thousand of the weight and what has to equal. So it has to equal T1 over here, the original force, with e to the I mu theta, and this is going to be theta 2. So theta 2. This over here, uh, wait, did I do this wrong? Oh, I did this so wrong. Sorry, this is 1,000. Because what's happening with this is this plays as an additional function attached. So originally, you would have originally just say T1 and moved on and say T1, T1. Instead, there's another attached piece over here, and that's important. We play the same thing over here, where P equal, we translate the energy. So this is the local over here. Let's do another color. This is the local over here. Usually you would transfer it like this, but there's an energy loss that's in the form of mu theta. And this is what we have to describe over here. And this is an approximation, but this is a good approximation enough for our purposes. There's no I there, sorry. So this is also T1 E mu, and this is gonna be theta 1 because top is theta 1. And top over here is about 180. So theta 1 is equivalent to saying for now 180 degrees, and it's gonna be pi over 180 because it's in radians, so this is equal to pi. So about theta 2, although, you have to look at how it's addressed. So over here, we know that this over here is about 60 degrees. So if it's this parallel to this, then by rule of doing something like this, you see that by looking at this thing, you remember this? You see that if this is 60 over here, when we go over here, you see by looking at this, that this angle must be 60, but this is also like this, so this must be also 60. Okay, and now by looking at that being 60, well, a portion of this is like this because this is 90 degrees over here. We see that if you do this triangle, that's a regular triangle you see often. This will make this 60 degrees. So it's 180 minus 60, and then that equals that. But we do radians, so 180 minus 60, and then pi 180 is your finding solution. So I should go back to red because red is more visual. But basically now you have almost everything because um we can get some value from this. Yeah. This is pretty much it. This is am I forgetting something? I think I am. I think I switched something. I think if I remember correctly, I switched it. Yes, definitely. These two are switched. This should be T1 and this should be P. My apologies. Why? Because you're going over here. So if you're going in the inverse direction, this is T1, right? And you're going to over here, how much force do you need? So this is the right version. Sorry, my apologies. So in that case, it is 1,000. My tablet's not working for some reason. Oh, I think my pen is almost out of battery. It says 1,000 equal to P E mu theta 1 E mu theta 2 again. And if I remember correctly, that's 1,000 equal P E mu theta 1 plus theta 2, like this. And then if you want to get PP equals 1,000 divided by E mu theta 1 plus theta 2, and you just plug out the calculator. So again, I'm sorry, I made a mistake. I flipped these two. Basically, if you were to do 1,000 over here, you go over here and see a change over here, and you go over here and see T1, and T1 goes over here. See another change over here. It's like a series of cycles. So now we do go to the calculator. I'm not making this video. It's like almost 2:30 at night a.m. So I'm just gonna be lazy about it and not read the video, man. It's already very late. So that's pi, so parentheses pi, plus parentheses division of 180 minus 60 uh, divided by 180, and then pi, enter. There's a syntax error I made apparently. What syntax error? I know there's a parentheses that I missed. It's not. Oh, I made another syntax error? Is it the multiplication here? Oh yeah, I did. I get. Wait, that's ridiculous. That's not the right. Oh, I forgot 0.3. My apologies. There's a 0.3. Okay, I got 207. That's about this. So 207 point, I get 207.8. So I'm assuming it is basically me basically B and rounded up. Okay, next question. All right, a boat is moored to a dock with a rope tied to the pole as shown. If the tension of the rope is 1,000, what is the torque exerted by the pole? Okay. All right, we can do this question. The real question is that all the information I'm given? Yeah, that's not enough information. Oh my God, I see. There's a few parts of this question that hasn't, I think that got missing over here. Um, so this is going to be a red question, and I'm going to move this all the way down, and I'll fix this question because this is clearly missing parts of it. You can't tell me that there's parts not missing. And you know what? I'll just leave it there actually. Control Z it and then Control Z, move it back there, and I'll fix it later. Because I'm lazy. All right, the five forces over here at point A. What's the magnitude of the resultant force? Okay. Um, wow. Wow. This is just a tedious little question, isn't it? That requires me to do like 16 additions or something. It's not really I mean it's a question nonetheless. And one I'm willing to do. All right. Summation of fx first. This is not even a static question. This is just a movement question. So Fx, we know 30 newtons is already in play. We know we have to plus 45, and it's going to be cosine of 30 plus 60 cosine of 60. And this will be 0. It'll be minus 90. It'll be sine of 30 equal what? This is not even a dynamic question. This is just a pun question. Cosine 30 parentheses plus 60 cosine 60 parentheses plus minus 90 sine 30, right? And that is 69. Okay, and then we do summation of fy, which says 75. Okay, so it's gonna be it's gonna be like this. So all of them are positive. So plus 90, and this is gonna be cosine of 30 plus 60, and this is you can do cosine of 30, and then we can do plus 45 cosine of 30, and we can do, oh, that's it. It's gonna be 45 plus 90 cosine of 30 parentheses plus 60 cosine of 30 parentheses plus 45 cosine of 30 parentheses, and I get 343. Oh wait, I think I messed up somewhere. No, I think, well, three. Okay, let me just double check this again. Um, yeah, it's just a little tiny mistake here. I need to sleep. definitely for sure. 45 is strangling, and the cosine theory, 90 cosine theory is right. Um, oh, and then there is 60 cosine theory. Is it in radians or something? Yeah, no, it's not. Plus 45 cosine, 60, sorry, my apologies. That's 227. Am I so sure about the 69? Let me double check the 69. Okay, it's 30, 45 cosine 30, 60 cosine 60, yeah, and then minus 90 sine 30. Yeah, that sounds about right. So, oh, I did not put it right in the calculator, although this is 53.97, and now we do 227 square plus 53.247 square, which we could just round up or round down, doesn't matter. Square, that's a 9 actually. So, and then we get 233.33 newtons. I think it's because of the round down as a resultant. So that's D. I think I round down somewhere. That's fine. Okay. No, I definitely should be sleeping, but we'll do a few more. Bracket is subjective to a force that is coupled. Determine the equivalent force coupling of the applied at point A. Where's point A? Point A angle. Okay, what? Point A. Oh, point A. Okay. Positive force upward to the right. Okay, so so you want me to figure out A. Am I correct to assume that? I think so. No, that doesn't. What are you trying to figure out? Let me just reread this. Force bracket support on a force should determine the equivalent force coupling to be. Oh, yeah, force it. Yeah. No, yes, yeah, I am correct. So there's a bunch of moments here, and luckily, this moment by doing this is actually a global moment. And you can just add it to your moment of A, basically, without any charge or any of the weird stuff you have to do with the other ones. So we start with the classic summation of all the stuff. This is external also, external. We're not dealing with internal stuff yet. So summation f x basically equal to 0. So 200, right? And then that's the minus direction. There's another minus, which is going to be 150. It's going to be, if I have theta over here, it's going to be cosine. Thank you. Cosine theta equals 0, summation, minus 200 minus 150, and it will be cosine of 3 over 5 in this case equals 0. Oh, I forgot the plus a. So, and then it's going to be plus or minus a. I think I'm going to do plus a, so we're going to define it as plus a for now. X direction equals 0, so plus 8x equals 0. So ax equals this. So let me just calculate it. And then that is minus 200 minus 150. So multiplied by division, 3 divided by 5. Okay, that's minus 200. So I get 290. Am I correct about that? Yeah, I think I'm correct. I get 290 as our reflection. Now we do a summation on the why is my mouse not working? Y direction equals 0. So over here, we're doing this as our positive direction. So we already have minus 150, and it's obviously going to be 4 divided by 5 because we have tried the 3 one. So it's going this way, and then there is a plus 150 apparently, and then I chose plus AY equals 0, but I think it might be a minus here. So let me just do this real quick because it's AY equal 150, 4 divided by 5 minus 150. Multiply, divide, 4 divided by 5, minus 150 equal minus 30. AY equals 30. So for now, what we have is basically AX equal 290 this way, and then this way 30 degrees. So second square root of 290 square plus 30 square equals 291. So it's one of these two. These two are out. And then we knew our arctan. Actually, we could just figure out from the moment or the at point. We don't have to do the moment at all. We can do the moment just for practice, although we will, because we can. So we already know which direction it is. So if you were to do arctan, so let me just do arctan, and it is the y divided by the x, which is going to give you 5.9 degrees. But you can always, wait, north? Uh, why is it saying north? Oh, wait, It's not looking for internal, is it? It's looking for external? But no, I'm right. It should be, yeah, yeah. So I must have messed up some of it. No, no, no. I'm mad confused a little bit. Okay, so it's 180 minus this maybe? It's 174. I see. And then 170 plus this is 185, I'm assuming. In this case, I have to go with probably C because I think I messed up one of the signs over there. Um, because I don't think it's at 174. Uh, but I messed up the sign. This is why you do a summation of moments and should have given you everything you need. Um, because the summation of moments should be 0. We can do actually, why am I doing this? I can just redo the yeah. Yeah, I think I messed up on the fx side. Equals 0 summation or something. It's looking for determinant equivalent force, couple force to be applied at point A. So over here, actually, yeah. And the fx was basically 200, I said. No, this is the right direction then. Yes, and basically this is the direction we're going. Is 0 degrees over here then? And over here then is 865. Okay. Clockwise. Ah, so yes, it's C. I bamboozled myself a little bit. Yes, it is C. It is definitely C. Yeah, as you can see. Hmm. Not impressed myself. Okay. A diagram is set free in the horizontal bar and experience a gravitational force at 50 newtons. What is the force between the bar and the block? Actually, do you want me to do the moment? Nah, I don't want to do the moment. I'm lazy. Okay, not lazy. I just feel like I have better use of my time by doing the next one, especially since I am falling asleep. I actually want to finish like a bunch of these, like at least to like a certain extent. So I know there's tomorrow, but we can do it. Well, if we can do it right now, we can. So first off, we have a force this way, a force this way, and looks like a tension force that could go this way, and a pulley system this way, frictionless pulley. So there's this over here, but notice that there's no IX except for IX, so AX must be 0. And then there is a summation of AY. What were we looking for? What is the force between the bar and block D? Wait, what? What am I looking for? There's a secondary force, apparently. Oh, because of the tension? Okay. Okay, that's interesting. So, according to this block, this is going to be 50 minus T then. And this tension force is bringing back from here, which is basically T1. And T1 is over here. T1 is over here. Oh, interesting question. And there's 25 newtons over here, which is permanent. There's a 50 newtons over here, but initially, the bar experienced 50, but you don't know what's happening. So it's 50 minus that. Okay. And then it's basically X and Y. So the summation of Fy equals 0 is basically AY minus 50 minus T1 minus 25 plus T1. Uh, that equals 0. Okay, so basically that gives me nothing. There's no reason for me to use that, so let's just go to moment immediately. Because obviously, it's clearly asking me to do a moment over here to figure everything out. Because the two forces did nothing. So a moment summation equals 0. So let's do a moment on here to get rid of the AY variable over here. So over here, that's 0.2. So we could do uh 0.2, and this is going this way from A, so that is a negative. That's a 50 minus T1, and then another one that is minus, right? 25 parentheses over here is 0.2, 0.1, so 0.3, and then it's going to be 0.6, so plus 0.6 T1 equals 0. Equals 0. So in this case, you have to do minus 0.2 multiplied by 50 plus 0.2 multiplied by T1 minus 25 multiplied by 0.3 plus 0.6 T1 equals 0. So if I do T1 equal 1 divided by, so 0.8 and divided by 0.8 over here, so 0.8 over here, and divided by, and then you just have to switch the signs over here. So we just put a negative over here, and just keep the sign over here so it makes it easier. Um, 3, about 25. Uh, minus because I want to keep the sign. And that should be it. 1 divided by 0.8, negative 0.2, multiplied by 50, minus 0.3, multiplied by 25, parentheses, parentheses. Oh, another syntax error. Who knew? That made another syntax error. Probably over here. Multiplied by negative. Yes. Okay, I get 21. I get C, and I think that's the answer. Hopefully I'm correct. Okay. We're moving on now. Wait, C? Okay, let me double check. Because according to this, it's rounded up over there. So I think. Oh wait. Sorry, I just realized that's a trick. That's not right. So T1 equals 21.875, but it's 50 minus T1. So it's 50 minus that answer. So it's 28, so it's D. Okay.